All right, linear functions, 2.5. So we now want to get a little more specific as we talk about functions. We're going to grow these through the next few chapters as well. So we'll kind of pick up linear here in Unit 1 and Unit 2. We'll look at quadratic and just build on those different things, because that's kind of the goal of college algebra. Look at the different functions and get a more in-depth look at them and see what we can do with them and what they mean for us. Okay. So let's start here with linear functions. So let's look at our definitions. And so our first one is that linear. Linear function. This is any function that can be described. I think I'm spelling that one out. I'm good. Described by f of x equals mx plus b. So we have our function f of x, and then we have m, which is some number times x plus some other number with that. Notice there's no powers, any absolute values, fractions with x on the bottom, those types of things. It's just that simple. F of x and x, and the other things are just numbers that are going to be on it, be multiplied, added, subtracted, those types of things. Okay. Our second piece here is y-intercept. This is where the graph of the function crosses the y-axis. Okay, and then for our purposes, we'll see that typically this is going to be this b value we see up here. Okay, in linear it's going to be that b value, but in other functions it's not. But we're to graph this where it touches, it crosses the y-axis. That is the y-intercept. Intercepts the y-axis at that ordered pair. Our third definition, probably our biggest one here, is slope. This is one of the most important for us. Slope, this is the steepness of a line. Okay, so how steep is my line with that? The bigger the number, the steeper it is. Okay, for those. So we want to be able to find those. How steep is my line? We use that in real life. We talk about steepness of a hillside, steepness of your roof. They call them other words. They may not call them slope. They call them pitch or grade, those types of things. If you go and drive in the mountains, they'll say steep grade, which means steep slope. And so you want to know what that is and make sure that your vehicle can handle it. Or your roof, you need to make sure that you have a pitch or a slope that will allow rain to run off of it, but not so steep that you can't get up there and do anything with it, right? For those. And so there are definitely some of those real world applications for that, okay? Now for slope, we use the letter M. So over in our equation, you can see the letter M. That's going to be our slope for us. But we have some different representations according to what we have. If we're looking at a graph and want to calculate slope, we would be doing what we call rise over run. How far does it go up compared to how far does it go left or right? Or how far does it go down compared to left and right? Those types of things. So we call it the rise and the run. Another way that we represent it is through some math words called change in y divided by change in x. Okay, so change in y over the change in x. Now, some of you may decide to go on and do other math courses. You decide to go into more upper level. You may see some math symbols. And so you would have kind of a triangle here. It's actually a delta symbol in Greek. And so that means change in y over change in x for those. Okay. And then one last way that we'll represent this is through ordered pairs. Y2 minus Y1 divided by X2 minus X1. Now the little subscripts means that's the ordered pair it came from. The Y and X with 1 on it came from an ordered pair. The Y and X that have a 2 on it, that comes from another ordered pair for those. So if we have 2 ordered pairs, we can find the slope between those 2 ordered pairs for them using this formula for those pieces. Okay, so I'm just going to kind of put that note out here. This is slope formula. That's what a lot of people call that. Okay, and we're going to use that here in just a little bit. We've got one last definition, and that is slope intercept form. Okay. Slope intercept form. Now we're going to put this in terms of y, and that is going to be y equals mx plus b. Or you could say f of x equals mx plus b. This up here is also slope intercept form. We interchange f of x and y for those, but that's the same thing. Okay. Now I've already kind of mentioned those couple of pieces, but remembering that if I get it in this form, y equals mx plus b, that the m is our slope, and that this b, actually all of that, sign included, is our y-intercept. So just being able to get it in that form tells me a lot of different things. We're going to look in the next section on how to utilize that in our graphs and be able to do some things maybe a little bit quicker. Okay? But today we just want to identify them, so that's what we're going to do here. All right, so let's get started in our examples and see what we're going to do. So examples. Find the slope and y-intercept. All right, so y equals 4x plus 5. All right, now, in order to find our slope and our y-intercept, it must be y equals and then our equation, okay, the rest of our equation. Since we have that, that means I can jump straight to my answer. Sorry, I want my slope, m, my y-intercept, b. I'm going to use m and b for that. The computer may write out slope, it may write out y-intercept, but it's the same thing. So my slope is the number in front of the x. No matter where the x is, it's the number in front. So that's 4. Now my y-intercept, it is this number here, including the sign, but it is an ordered pair. Okay, the y-intercept is where it crosses the y-axis. It has to be an ordered pair, so I have to write it that way. So when it does that, it's always going to be 0 in this number, including the sign. So make sure that you write it correctly for those. And there would be our answers. Okay. All right, here again, I have y by itself. So y equals x minus 7. So since y is already by itself, we know we can go ahead and say, what is m, what is b? M is the number in front of x. Since there's not a number shown, we have to remember it's a given 1. So that is 1. Because we have an x, it's 1x. And then for b, it's always going to be 0, comma, we take the sign, so -7 for that. So remember those details. Okay. Right, number 3. 2x plus 3y equals 6. All right, so this time y is not by itself. So we have to get it there. We can't just say, hey, the number in front of x and the number by itself is the slope and the y-intercept, it has to be in that form where y is by itself. So we must do that. So this is kind of where that applications that we did before, we're isolating the variable when we have other variables that comes into play. So to get y by itself, I'm going to subtract 2x to the other side. So that says 3y equals negative 2x plus 6. All right, I can't put those together because they're not like terms. So I subtract this 2x over here, and I always like to put my x first so it fits that form mx plus b. But y is still not completely by itself. We need to divide every single thing by 3. So if we divide by 3 here, we're going to get y. We divide this one by 3 and reduce, we get negative 2 over 3, and then the x is afterwards. We take 6 and divide by 3, and we're going to get 2. So now we can see that my slope is negative 2/3, and my intercept is 0, 2. Okay. All right, let's do one more. 3 minus 1 over 4y equals 2x. Now our process still remains the same here. Okay, maybe moved around differently, but we're still kind of trying to get y by itself. So subtract 3 to the other side. Negative 1 over 4y equals 2x minus 3. Now we see that we have a fraction. We don't really like fractions, so we can get rid of those by multiplying by the reciprocal. So I'm going to multiply everything here by the reciprocal, which is negative 4, or 4 over 1, negative 4 over 1 with that. Okay. Well, negative 4 times negative 1/4 is a positive 1y. Negative 4 times 2 is negative 8x. Negative 4 times negative 3 is a positive 12. So that means that my slope is negative 8, and my intercept is 0, 12. So those are different ways that these are going to be represented. You're going to have to show those steps. You have to show getting y by itself, and then tell me what is the slope and the y-intercept for those pieces. Okay. All right. One more style. So we've got to use that formula I gave you. We want to find the slope. One. We have 6, 9, and 4, 5. I want to find the slope. Okay. All right, so this is going to be where our equation comes in, our formula. So I'm going to put our formula up here as a reminder. It says that m is y2 minus y1 over x2 minus x1. And we're going to use that. Okay. All right, now let's kind of write down, we have our m. We're going to have a fraction. And we're going to have some things being filled in. I do recommend that you put these parentheses on here like I'm doing. For this in particular problem, it's not going to matter, but we're going to have negatives later on. And we want to make sure we get our signs done correctly. So put those things in parentheses so that you don't screw that up. Now, where it goes where? Well, remember, these are x1, y1, x2, y2, or vice versa. As long as they both have the same numbers, that's fine. And so here I'm going to plug that in. So it says y2 is 5, y1 is 9, x2 is 4, x1 is 6. And then we can do the math. 5 minus 9 is negative 4. 4 minus 6, that's going to be negative 2. And then we do that division, or we reduce. Okay, so -4 divided by -2 is a positive 2. All right, let's do another one. Let me erase this down here. So number 2. 9, -4, and 3, -8. All right. So again, I'm going to put my slope, put my parentheses. I'm just going to do that before I do anything else. Now we can also say x1, y1, x2, y2. That way we can see those. Now, you don't have to do all that as far as the x2s, y2s on those. So if you can write it all down correctly, that's just fine. All right, so y2, we say -8, y1 is -4. x2 is 3, x1 is 9. All right, so -8 minus -4. Minus and negative is plus. So -8 plus 4 is -4. 3 minus 9, that's -6. So we need to reduce that. Negative over negative is a positive. And then 4 and 6 can be reduced by 2. So we get 2/3 for that one. So that's what you're going to be doing on these problems. We have negatives, we have fractions. You have all those different things that go in there. You follow your adding and subtracting rules when it comes to those pieces. Being careful. We've got to be able to find the slope and y-intercept, whether we're looking at an equation or whether we're looking at ordered pairs, because we're going to need that moving forward. So you really want to spend a little extra time on this, making sure you have it down and can get it right every single time. Okay? So that is what we're looking for in this section.